Welcome to this video about BCD decoders. In this video, we will cover what a BCD decoder is, alongside why and how BCD decoders can be used. First of all, what is a BCD decoder? A BCD decoder is an IC, which implies that inside this little BCD decoder is actually an entire circuit. To better understand any IC you encounter, you could follow these 6 steps, which are explained in more detail in another video. We start with identifying the IC. Suppose that we wish to consider the SN74LS47N, which is one of many BCD decoders available on the market. Now that we have chosen which exact BCD decoder we wish to consider, we can move to the second step, getting the datasheet. We are going to need this when we dive into the details later on. But before we get into these details, we should ensure that we have a basic understanding of the BCD decoder. So what can a BCD decoder do? To illustrate this, let's consider the following example. Suppose that I have 3 7-segment displays on which I want to display a number code of 3 digits. The most straightforward way to do this would be to connect and control each segment individually. In that case, I would have exactly one connection for each segment. But this would imply that if I want to show a 3-digit code, I need a total of 7 times 3 equals 21 connections. Now this would be a problem if I wanted to control the number code that I want to display by using a microcontroller such as the Arduino R4, which has only 14 digital output pins. This is where the BCD decoder comes in. The BCD decoder can help us in 2 ways: by allowing for easier control of a display and by reducing the amount of pins required. These are the 2 main uses of a BCD decoder, and it is able to do so by converting binary inputs to data or signals that can drive specifically a display. How is that possible? Well, to understand that, we will need to dive into the details of the BCD decoder. Let's have a look. The details of the BCD decoder can be found in its datasheet, which shows information such as the pin configuration, the input and output voltages, as well as the desired supply voltage. It also shows the relation between the inputs and the outputs. In the datasheet, we can see that the SN74LS47N has 6 digital inputs, 7 digital outputs, 1 digital I/O pin, a pin for the supply voltage, which is the VCC pin, as well as a ground pin. The logic diagram of the datasheet shows that the inputs are related to the outputs according to a combination of logic gates. For instance, you can see the AND gates, the NOT gates, and the NOR gates. To help you understand how the different input combinations relate to the output combinations, the datasheet also contains a function table. Here you can see that if LT, RBI, and BI/RBO pins are all high, so a digital 1 and thus an high input voltage, and inputs A, B, C, and D are all low, then the 6 outputs A, B, C, D, E, and F are all on, and only output G will be off. If the outputs of the BCD decoder are then used to drive a 7-segment display, you can turn on 6 out of 7 segments of the display. For instance, to show the number 0 on the display, which requires you to turn on 6 segments from the 7-segment display. By changing which of the inputs A, B, C, D are high, which represents a 1 or a high voltage, or low, which is 0 or a low voltage, you can control which of the outputs are high or low, and thus which of the segments of the display light up. That will determine which number is shown on the display. As mentioned before, apart from the ABCD inputs, there are also the LT, RBI, and BI/RBO inputs. The LT input, which stands for lamp test, can be used to set all outputs to high, and thus turn on all segments of the display, irrespective of the inputs given to A, B, C, and D. The BI/RBO, the blanking input, can be used to set all outputs to low and thus turn off all the segments of the display, irrespective of the inputs given to A, B, C, and D. Finally, RBI, which is the ripple blanking input, can be used to enable or disable the use of the 0 as a number on the display. You might wonder what happens if you try to use LT and BO/RBO simultaneously to set all outputs both high and low at the same time. This can be fun to investigate yourself. Check the datasheet to make an expectation, and then you can check your expectations in reality. Okay, so now we know that a BCD decoder can be used to convert a 4-bit binary input to output signals that show the corresponding decimal number on the display. Furthermore, the BCD decoder allows you to use less of those precious output pins of your microcontroller. However, the BCD decoder is not the only IC that can do this. Another way to do this is by using a shift register, which will be discussed in a separate video. Make sure to watch that video as well. After watching the video about the shift register, I will show you how you can combine BCD decoders and shift registers to drive multiple 7-segment displays, with only a few output pins from your microcontroller. By doing so, you can truly unlock all the possibilities and functionalities you might have for your 7-segment displays. Because when everything's wired just right, the digits really add up. Now go on, make it count.